Hello friends, welcome back to our channel. So today we'll see one more concept in a dynamic programming in algorithms, that is a traveling salesman problem. So this problem we'll solve by using the dynamic programming method. So in our previous session we have already seen what is a dynamic programming, right? So a complex problem will be divided into subproblems and each subproblem will be solved and the solution of each subproblem will be saved in the memory, so that in future, in order to avoid the recalculation, so we'll make use of the existing solutions. And this is also mainly used to solve the optimization problems where there will be a lot of solutions. Among them, we have to select the optimal solution based upon the given constraint. So this is about the dynamic programming. So about all this dynamic programming we have seen in our previous sessions. So I'll post the link in the description. So just go through. And now we'll see what is a traveling salesman problem. So here, first let us see what is this problem. So there will be a graph. So here we are supposed to take a graph. Okay, so consider different vertices and edges. We know that a graph will be having vertices and edges. So how this graph is related to our salesman problem? So consider the edges as a distance and vertices as a places in the city. So how the salesperson travels from one place to another place, covering all the places in the city with a minimum distance. Okay, so assume each vertex as a place in the city, so that from the source, the salesperson should start traveling and have to visit all the places only once. Okay, all the places only once and have to come back to the source. So this is the salesman problem. That's also with a low cost. That means distance, least distance. So for that relation, we are taking the complete places as a vertices and the distance as a edges, so that we can have a graph and we can solve it. So one thing, we have to select a source. So selection of source. That's the first important point. And the second one, so starting from source, traverse through all vertices in a graph exactly by one time and come back to source with minimum distance or cost. Minimum distance or cost. So we have to select the source node, and from that source node we have to traverse all the vertices exactly one time and come back to the source with a minimum distance or cost. So for this we have to consider a weighted graph. So every edge should have an weight which represents the distance or a cost, whatever it may be. Okay, so we have to consider weighted graph. And one more important, so we can have the directed graph or undirected graph. So graph can be directed or undirected. So I think you know the difference between this directed and undirected. Okay, for example, if A, B, C and this is a graph. Okay, this is a graph. So there is no directions on the edges. So this comes under undirected. Undirected. For example, A, B, C. Okay, so there is a directions. So there is a direction. That means this edge is between A and B. This edge is between B and C. This edge is between C and A, right? So there is a directions. So this is a directed graph. So we can work this problem, traveling salesman problem, either on both directed or undirected, but it should be a weighted graph. So for every edge there should be a weight, okay, which represents the distance or a cost. And one more important point is the graph, either directed or undirected, the graph should be complete graph. Complete graph. So what do you mean by complete graph? So every vertex should have the edge to all other vertices. Okay, for example, consider A, B and C. So this is an undirected graph. So we can say this is an edge between A and B and also B and A. For example, let us take the distance. So this implies the distance between A and B is 10. Similarly, the distance between B and A is also 10. Distance between A and C is 20. Similarly, C and A also 20 because undirected. So if it is like this, A to B, B to C, C to A. So this is also an directed graph, but not a complete graph, because A is having an edge from A to B. There is no edge for A to C. And B is having an edge for B to C. There is no edge for A. C is having an edge for A. There is no edge for B. So the complete graph means every vertex should have the edges towards all other vertices. For example, so A is here. I will write one more edge here. So A is having edges to B and C. Now B is having only for C. I will write here. So B is also having an edge from A and C towards A and C. So C is having only for A. So C is also having an edge to A and B. So A is having edge to B and C. B is having an edge to A and C. C is having an edge to B and A. So this is a complete graph. This is the complete graph. Complete directed weighted graph. Okay, so this is a complete complete directed weighted graph. Okay, so in such type of graphs we can apply this traveling salesman problem. Okay, so these points are most important before starting the problem, right? So selection of a source, we can select any vertex as a source, but from that particular vertex we have to traverse all other vertices exactly once and come back to the same vertex. And consider a weighted graph, so that should be a weighted graph, can be a directed and undirected graph, should be a complete graph. So these points are most important, right? Now, so before going to this one, let us have a formula. So just remember the formula, so that while solving the problem you can understand the formula exactly, right? So here we'll write a formula. The function I comma set, S stands for set, which contains a number of elements, or we can say vertex, right, is equal to cost of I comma j. So j, so here, okay, I'll write here itself. I'll erase this one. I'll write here. So G of I comma set, which contains all other vertices, is equal to minimum of J belongs to set cost of I j plus again a function j comma set minus j. So this is a formula which we have to remember while solving the problem. And one more formula, G of I comma pi is equal to cost of I comma source. I comma source. Okay, right. And one more thing, remember one more thing, cost of I comma j will becomes 0 if I equal to j, and becomes cost of ij if ij edge belongs to graph. Ij belongs to graph. That means if there is an edge between I and j. Okay, so just remember the cost, if I and j both are equal, then the cost will be 0, right? Yes. Otherwise we can write down the direct. So remember this formula. So we need to calculate the shortest path from source, visiting all vertices and come back to the source, right? So I is a source, okay, I is a source, and S is a set of all vertices other than I. Okay, from that we have to find out the minimum. Okay, so we'll write down the example. So let us take this example. Okay, so this is a undirected graph. Okay, first let us check. It is an undirected graph. This is a weighted graph because for every edge there is a weight. And let us check whether it is a complete graph or not. So here we are having a 4 nodes, that means a 4 vertices. So every vertex should have the 3 outgoing edges. So A is having an edge from A to B, D and C, right? From B to A, B to D, B to C, okay? C to B, C to D and C to A, okay? D to A, D to B, D to C, yes. So this graph is a complete weighted undirected graph. Now we have to solve the problem. First let us write down the table. Okay, let us write the adjacency matrix. So I am writing here, so A, B, C and D, and here also A, B, C and D. So we'll write the cost. Okay, so this is I and this is J. So there will be no edge from A to A or B to B or C to C or D to D. So that's why I have mentioned, so cost of I comma j will be 0 if I is equal to j. So if I is equal to j, then the cost will be 0. And it will be Cij if the edge ij belongs to graph. Okay, see, A to A. So I is equal to A, j is equal to A. Obviously it will be 0. Next, A to B. Then if there is an edge, A to B, yes, there is an edge. So belongs to graph. Okay, A comma B belongs to graph. So that implies the cost is 10. Next, A to C, 15. A to D, 20. Similarly, B to A, 10. B to B there is 0. B to C is 35. B to D it's a 25. Similarly, C to C again it's 0. C to B is 35. C to C 0, C to D, it's 30. Similarly, D to A, it's 20, D to B, it's 25, D to C, it's 30, and it is 0. Okay, sorry, C to A, 15, it's not 0, C to A, it's 15, right? So this is an adjacency matrix. Okay, so this represents a cost from one edge to another edges. It's clear. Now, so just start with the set 0. Okay, if the set contains 0, what are the different possibilities? If set contains one element, what are the different possibilities, different edges? Now, we'll select the source. So I'll write source as A. A is a source. Okay, A is a source vertex. Now, first, if set is equal to 0, okay, the set contains different elements. Okay, so 0th element, first one element, 2 element, 3 elements, because the source is A. So if set is equal to 0, if set is equal to 0, apply the formula G of I means B. So from B, comma, set is 0, there is no element, so that can be represented as pi. If set is equal to 0, then we can represent it as pi. Now what happens? See, if I 0, then I comma source. So this will be G of, what is I here? B, comma, what is the source? A. So what is the cost here? B to A. B to A, it is a 10. Similarly, there is a possibility of C to pi. C with no element. So G of C comma source, which is nothing but C to A, it's a 15. Similarly, G of D comma pi, G of D comma A, which is DA, it's a 20. So which means if the last vertex is B, if the last vertex is B, obviously our statement says that we have to visit all the vertices and come back to source. So that's what happens. So if the last vertex is B, then what is the edge from B to source? And if the last vertex is C, C to A, that means, for example I am saying A is here, the next edge can be B, C and D. From this, if B, the next edge can be C and D. Next edge can be B, D. Next edge can be B, C. And A, B, C, obviously it will be D. A, B, D, obviously it will be C. If A, C, B, it's D. A, C, D, it's B. A, D, B, it's C. A, D, C, it's B. So only one vertex. So all the vertices have been visited, right? So this is a possibility, maximum possibilities, all possibilities. So after coming to D, what's the next move? So visited all vertices here. So it should go back to A. Similarly, if it is C, it should go back to A. If it is D, again it should go back to A. B, go back to A. C, it should go back to A. B, it should go back to A. So that's what here we have written. If B with a null set, if B with a null set, that means no other vertices are remaining to visit, then obviously the next move will be from B to A. And that means at this position, if there are no unvisited vertices, if set is 0, no unvisited vertices, obviously the edge should be towards the source. So that's why we have written this formula, I comma pi, then I comma source, right? So hope you understood this one. And the next possibility, So only three possibilities, because we are having four edges, four vertices A, B, C, D, and here we have taken source as A. So we need to check the possibilities of all the remaining three, B, C, D, right? Now, if set is equal to 1, that means if there is only one unvisited unvisited vertex. If the set contains unvisited vertex, only one unvisited vertex, then possibilities G of B, and the unvisited from B, where it can go, either it can go to D or B, it can go to C. Only two possibilities. Okay, only two possibilities. So if there are one more vertex, for example, if there is one more vertex, then we can write it here, G, B, comma, E. That means there can be edge between B and D, B and C, B and E. So anything, right? So the set contains 1 means having one unvisited vertex. So always I am getting edge, right? So that's a vertex. Okay. So write down the formula here, B, D. So what is the minimum of J belongs to S? Here J means D. D belongs to set S. So Cij, that means C, B, D plus G of J comma set minus J. J here D, D comma set minus D. So here set is nothing but D. See, here set is nothing but D. So D minus D, obviously it will be empty, right? So empty means we can simply write it here, pi. Okay, so there is no other edge, only one edge is here. So only one unvisited vertex. So we are just getting the cost of that particular unvisited vertex. So if there are multiple, obviously we can have to select the minimum edge. So here we are having only one thing, so we can simply remove it and we can write it C HBD plus G of D comma 5. Okay, so you can see what we have done in the dynamic programming. So we are dividing the complex problem into subproblems, and we are calculating each subproblem, and we are storing in the memory. So that's what we are doing. So here G of D comma 5, we need not recompute it. So already we have recomputed. So D comma 5 is this one. So obviously we can get the value from here. So CBD plus G of D comma 5, which means cost of B and D, it's a 25 plus 20, D comma 5. So which is 45. Now again, G of another possibility. So there can be an edge from B to C. So this can also be written as BC plus G of, so what is the J here? C comma set minus C. Obviously it will be pi. So the edge between B and C, BC 35 plus G of C pi, it's a 15. So which will be 50. So here we have taken B as a source and we are computing the cost between B and all unvisited edges. See here, next change it, C to B. We can check the possibility. If C is a node, and we have to check from C to all possible unvisited vertices. So C to B, and similar here, CB plus G of B comma set B minus B. So obviously it is pi. So which will be CB 35 plus G of B 5 10, which is 45. And similarly, from C, there might be having an edge to D. Okay, C to B. Okay, now C to D. Cost of CD plus G of D comma pi. So cost of C comma D, C to D is 30 plus D pi 20. So which is 50. Hope you understood. If set is equal to 1, we need to, the set is 1 means 1 unvisited vertex. There is a one unvisited vertex. Okay, so we need to check all the possibilities towards that unvisited vertex, right? So if you consider B, B to D and B to C. If you consider C, C to B and C to D, because we are having only 4 vertices. So if our graph is having the 5th vertex, so here we'll get one more thing, G of B comma E. Okay, that's also one possibility. The same thing, right? Now, consider set is equal to 2. That means 2 unvisited vertices. Unvisited vertices. Here also we have to go with the different possibilities. Check it. G of B, consider B as a source. From source, 2 unvisited vertices will be either C comma D. Okay, C comma D, unvisited vertices. So how we can write it here? Here we can write minimum of, okay, first cost of BC and cost of BD plus G of, what happens here, C comma, okay, set C comma D minus J C plus G of D comma C comma D minus D. So among these two we have to find out the minimum from this formula only, right? J belongs to S, C, I, J. So C, D are the 2 elements in the set. So BC and BD. So in this case, J value is C. So G of J value C comma set C comma D minus J minus C. And in this case, J value is D. So plus G of D comma C comma D set minus D. So obviously you can see set C comma D minus C means it will be D. Okay, and here C minus D means it will be C. Hope you understood. So among these two, we have to select the minimum. So that's the formula. And in the previous case, we are having a set with only one element. Okay, only one unvisited node. So we are having only an edge between B and D, B and C, C and B and C and D. Now we are having 2 unvisited vertices. We are having 2 unvisited vertices. So there can be a chance of having an edge between B to C and B to D. B to C and B to D. So among those we have to select the minimum cost. So that's why minimum BC plus this one. And here, and this will be BC 35 plus G of C comma D. Already this was calculated here. C comma D, which is 50. So which is 50, 85. And coming to this one, C of BD 25 plus DC. Already we have calculated here. Oh, we have missed it. Yes, we missed it. I'll write here G of D comma C. So we have missed it. We have calculated till CD. So for D also we have to calculate. and DC. So C of DC plus G of C comma 5. So which is DC 30 plus C pi 15 is equal to 45. There is one more possibility. From D there can be a chance of edge to B. So this is one more chance, right? So C of dB, that means the cost of dB plus G of B comma 5, similar to this one, right? Similar to this one. So what is the cost here? dB. So D to B 25 plus G of B pi. G of B comma pi. Okay. So G of B pi 10, which is 35. Which is 35. Right? I'm sorry, the board is very small, so I'm forcibly adjusting everything in the single board, right? Okay, just right. Now here you can get cost. G of D comma C. D comma C cost is 45. So which is equal to 70. So which one is the minimum? 70 is the minimum. So you have to consider this one. Okay. Now again G of, if C is a source, what are the remaining elements? B and D. So minimum of CB, CD plus G of B comma, okay, from set we have to minus B, so obviously it will be D plus G of D comma B. So which is cost of CB it's a 35 plus G of B comma D, G of B comma D, which is 45. It's a 980. Okay, and this one CD, C to D 30 plus DB, here we have written DB 35, so which is equal to 65. So among these two, which is minimum? 65 is the minimum. So this we have to consider. And the next one, G of, what is the next? D. If the possible source is D, from D there can be edge between B and C. So here we can write B and C is equal to minimum of CDB CDC plus G of B comma, from set we have, if you minus B, the set will be containing only C, plus G of, if C is a source, and remain minus C from the set, so it will be B. So what is the amount here? Cost of DB it's a 25 plus BC cost is 50, 75, and here what is the cost here? D to C 30 plus CB, which is a 45, again it is a 75. So both the edges will be having the same cost, so we can select any one edge, no problem. Okay, so only possibilities, 3 possibilities we have chosen, right? If the source is B, there can be edge from B to C or B to D. If the source is C, there can be edge between C to B or C to D. If the source is D, from D there can be a source to B or C. Now, if set contains 3 elements, that means 3 unvisited nodes. So G of, here 3 unvisited means the source A, B, C and D, because here we are having only 4, right? Among 4, the 3 are unvisited, and obviously the next one will be the source. So I'll write here So which will be a minimum of C of AB, C of AC, C of AD plus G of B comma, if you subtract B from set, it will be C comma D plus G of C comma BD plus G of D comma BC. Okay, hope you understood this formula. So J comma, from set we have to subtract the J value. Okay, so here J value is B, we are taking B from set, so CD. Here J value is C, we are taking C from set, so it will be BD. Here D is a J value, so we are taking D from set, so it will be BC. Okay, so calculate the cost. CAB, so AB cost is 10 plus B of CD. So here we have calculated, and here we are having a two values. Among these we have to select the minimum, so 70, so which is 80, and the next one AC, A to C, it's a 15 plus CBD. Here also we have calculated two values, 80 and 65. So among these we have to select the minimum 65. So it is also 65 and the result is 80. And the third one, AD, cost of AD is 20. D of BC, which is both are same value, so we can select any value. So it is 75, which is a 95. So among these three, we have to select the minimum, and see, we have to stop the process because we are having a maximum of 4 nodes or 4 vertices, and among these the 3 are unvisited. So already we have fixed that one as a source, and only the possible are 3 more vertices, and we have repeated from 0 unvisited to 3 unvisited. So we have to stop here, right? Now among these we can select the minimum, but here you can see we are having two possibilities because two values are same, 80, 80, and we can't select this one because it is the highest. So we have to select either this node and this node. So the path, the possible solutions are A to B or A to C. So A to B or A to C. Okay, then first if it is A to B, the next one is B, C, D. Go to here, B, C, D here. So among these we have selected this one, right? So this one we have selected, B to D. Now B to D. And coming to this one, A to C. If A to C is one edge, then next to CBD, CBD. Among these we have selected the minimum, that is CD. So the next vertex we visit is D. Now if D, okay, this one we have selected. Next D comma C. Go to that thing, D comma C, this one, D comma C. So the cost is DC. The next one will be C. And similarly here also go to CD, DB. So DB means here. So after that the next node will be B. And after that, in both the cases, the next vertex will be A. So that implies there are two possible paths where starting from A, visiting first vertex as B, next D, followed by C, and come back to A. This is one possible path with a distance of 80. So you can calculate A to B, which is 10, B to D, which is 25, D to C, which is 30, and again C to A, which is 15. Total we will get 80. And similarly here, starting from source A, visiting first vertex as C, next vertex as D, followed by B, and come back to A. So in both the cases the distance is 80. So there are two possible paths. So if we are having only one among these three are minimum, so that will be the single path where the person can travel from source to visiting all vertices and come back to the source. So here we are just calculating and we are saving the result, and we are making using this result in further procedure, right? So hope you understood this problem. So one constraint, we have to consider the weighted graph, and we can consider either directed or undirected, and that should be a complete graph. Okay, only two formulas we need to remember, and based upon two formulas we can solve, starting from 0 unvisited link, 1 unvisited vertex, 2 unvisited vertex, and 3 unvisited vertex. So until n minus 1 unvisited vertex, we have to calculate this procedure, right? So hope you understood and enjoyed. So if you are having any doubts regarding this procedure, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.